solving rational equations and radical equations. So our objectives is we're going to solve the rational equations and radical equations. Equations containing rational expressions are called rational equations. Solving such equation requires multiplying both sides by the least common denominator of all the rational expressions to clear the equation of a fractions. So we have done adding and subtraction of fractions, and we had to find the least common denominator in order to combine them. So this is the same process, it's just a little bit more involved. So let's do this first example. If you notice here, we have 3 in the denominator and we have 2 in the denominator. So we need to determine what's the least common denominator, a number that both 3 and 2 will go into. Maybe not the same amount of times, but they will go into. So I can say 3 times 2, which is 6. I know that's the smallest number they both go into. And how did I know that? 3's prime, 2's prime. And I know if I multiply them together, I'm going to get the answer I need. So if I was to undo this fraction, I would need to multiply this first fraction by whatever's needed to undo it. So I'm going to multiply it by 6. I'm going to put it over 1 if it helps you. And I'm going to do the same to this next one. And the reason why we need to undo the fraction is because we have this variable involved in the fraction, and I can't solve for the variable as long as it's tied to the fraction. So now I'm going to reduce. I see that 3 goes in itself once, goes into 6 twice. 2 goes in itself once and goes into 6 3 times. So I'm going to rewrite this as 2 times that x minus 8. And then I'm going to put my plus sign. And then I'm going to say 3 times x minus 3, and it's all equal to 0. So next, I'm going to distribute the 2 to this parentheses. So now I got 2x minus 16. Writing down the plus. I'm going to say 3 times that x, and they're both positive, so it's going to stay positive. And then I got the positive 3 times that negative 3, and that becomes a negative 9 equals 0. What I'm going to do is put all the constant terms together and all the variable terms together. So I noticed that, and you can rewrite it. You can say 2x plus that 3x minus 16 minus 9 if you want. That makes it easier. 2x plus 3x is 5x. And then I have a negative 16. So it's like saying you have a negative $16 and you spend 9. So you're in the hole of negative 25. Set it equals 0. Now let's solve for x. Well, I can't solve for x as long as it's not isolated. How am I going to isolate it? I noticed that this negative 25 needs to be moved to the other side. Since it's negative, I'm going to add it. So now I have 5x is equal to 25. Now I'm going to solve for x, and I can't get a true solution or a solution as long as x doesn't have a coefficient of positive 1. And if you notice, it has a 5. So I'm going to divide by 5 on both sides. Now I have a positive 1 coefficient on x. It's equal to 25 divided by 5 gives me 5. Now, before I say it's my true solution, I want to check. I want to make sure it is a true solution. Just because you get a solution, don't mean it's true. So what I'm going to do is I'm going to plug it into my original equation that was given to us. And I'm going to see, is it true? Does it really equal this other side? So I'm going to plug in 5. So now I got 5 minus 8, so it gives me a negative 3 over 3, plus 5 minus 3 gives me 2 over 2 is equal to 0. Well, positive 3 goes into negative 3, negative 1 times. 2 goes into 2, a positive 1 time. Negative 1 plus 1 is 0. So therefore, this is a true solution. Okay, so moving on. Here's your next screen. So our next screen is just showing you how you can plot it in your graphing calculator. If you need any help, just please reach out. And it will show you solutions. It'll give you order pairs, and it'll show you if it's a true solution or not. Sometimes, even though it gives you the solution, you still got to check your work. So here we go. We have a fraction and variables involved in it, and I cannot solve for the variables until I undo the fractions. And I notice that the denominator is x minus 3, both of them. So that means that's my least common denominator. So if I multiply each fraction by it, what happens is they reduce because x minus 3 goes into itself once and goes into this one once. Same here. And that worked out nice and pretty. Now, guys, I cannot separate the x minus 3 because of the negative sign. It's made them attached to each other. So now I have x squared is equal to 9, and I want just x. So I know that if I take the square root of that x squared, the square and the x squared root reduces down. Then I have to do it to the same thing to the other side. However, I get a plus or minus because it's an even root. So now I have x is equal to plus or minus 3. Let's check our work. Let's make sure they are true solutions. So I'm going to check where x is equal to a positive 3, and I'm going to plug it in. Everywhere I see x in my original. Okay. So 3 squared is 9. 3 minus 3, what happens? It goes to 0. And then I got 9 over 3 minus 3, it goes to 0. This is undefined. Anytime denominator has a 0, it's undefined. So this is not going to be a true solution. The positive value is not. So let's check the negative value. So we're going to plug it in. Okay. So now I have negative, I'm going to come over here and solve it. Negative 3 squared is a positive 9. Negative 3 minus 3. So you're in the whole $3. You spend 3 more, so it's a negative 6. And then the next side is 9. And then I got negative 3 minus 3. Again, negative 6. I don't have to go any further because 9 over negative 6 is equal to 9 over negative 6. So I'm going to say that x equals negative 3 is a true solution. Okay. So you can check, follow these slides out if you want. All right, now let's talk about radicals. A radical equation is an equation in which variables appear in one or more radicants. So here's a radical. And I'm going to put in there because it depends on the root. Most of the time we're working with square, but there could be more, a larger root here. And then the radicands is what's inside the root. So, and this is a good example. I have square root of 2x minus 5 minus square root of x minus 3. This negative sign here, this subtraction, tells me I cannot put the radicands together under the same root. If it's multiplication, I could, but I can't here. So now we're going to have to find the principle of the powers. So if I have a positive integer n, a equals b is true, then we know a raised to n is equal to b raised to n is true. So this is just a definition here. Let's apply it. Okay, to solve a radical equation, we must first isolate the radical on one side of the equation, then apply the principle of powers. When a radical equation has 2 radical terms on one side, we will isolate one of them and then use the principle of the powers. If after doing so, a radical terms remains, we repeat these steps. All right, so in this one here, the radical is already isolated, so we're doing good. So what I need to do is undo this radical, right? Because I want to pull the radicand out. So since it's a square root, I know I can raise it to the power of 2. What I do to one side of the equal sign, I must do to the other. So the root and the power reduces and leaves me with the radicand. And now I got 4 squared. Now let's solve for x. Well, in order to solve for x, I got to get it isolated. I have a positive 1 constant here, so let's subtract it. So it goes 0 there. So now I got 16 minus 1, which is 15. I have a positive 3 coefficient on x, and I need it to be a positive 1, so I'm going to divide by 3. And what you do to one side, you do to the other. Now I got x is equal to 15 divided by 3, which is 5. Now let's make sure it's a true solution. So I'm going to plug it back in the original. Everywhere as I see x, let's plug it in. And we want to see if one side equals the other. So now I have the square root of 3 times 5, which gives me 15 plus 1 is 16. Square root of 16 is 4, and 4 does equal 4. So yes, this is a true solution. Okay. Tap through here. Okay, our next example. If you notice, I have a plus 5 here. So this radical is not isolated. So what I'm going to do is I'm going to subtract this 5 from both sides. So now I have the square root of x plus 7 is equal to x minus 5. And I want to undo the root, so I'm going to raise it to the second power. And I'm going to do to one side, we do to the other. Square root squared reduces down and leaves me with the radicand. And now what I have here, I have x minus 5 times x minus 5. So you can use the shortcut, or you can just do the distributive law or the full method, whichever one works for you. I know that the first term and in both parentheses are the same. The last term in both parentheses are the same, and the signs are the same. So again, if you wanted to use the shortcut, we know we would square the first. Take the sign that we're working with, in this case is negative, double it, multiply the first times the last, and then bring down a plus and square the last. If you don't like this method, then you can come over here and say, okay, I want to use the distributive. So I got x, or the full, I got x times x, which is x squared, x times negative 5, negative 5 times x, and negative 5 times negative 5. Combine the like terms. So now I got x squared minus 10x plus 25. And what do we got here? We have the same thing. So it's up to you which method it works for you. So now let's bring down this x plus 7. All right, now I need all the x, well, actually I just need to get everything on one side, and then I'm going to factor so I can find the values of x. So I'm going to subtract this x since it's positive, and I'm going to subtract the 7. And let's line them up with the correct terms. So I have negative 10x minus x is basically saying you're in the whole $10, you spend one more, so you're in the whole 11. I have $25 minus 7, so now you have what? 18. It's a positive 18. All right, now let's factor. So you can use the full method, you can use the quadratic formula, whichever one works for you. If you use the, not the full method, excuse me, guys, the AC method. You can use AC method, you can use the quadratic equation, just whichever one works for you is fine. If I use the AC method, remember it's the A times C, which in this case is 1 times 18, which is 18. And in this case here, if you notice, this is a plus sign, so it means it's a product that adds to what? Give me negative 11. So what is 18? 18 is 1 times 18. And we need it to be negative, and since they're adding, we know the signs are the same, so that's not going to give it to me. What about 2 times 9? Negative 2 minus 9? Yeah, that would work. So now, let's factor it. We know x is going to leave both parentheses. Got negative 2, negative 9. Now let's set it equal to 0, each parenthesis. I'm going to add the 2 to both sides. Gives me plus 2. I'm going to add this 9 to both sides. All right, now we need to make sure this is a true solution. So I'm going to erase some of this up here so we can have the space to check our work. Yeah, we just need some more space right here. All right. So I'm going to take my original, which is 5 plus the square root of x plus 7 is equal to x. And I'm going to plug in 2. I'm going to let 2 be my x first. So that gives me 5 plus 2 plus 7. Is that equal to 2? 5 plus 2 plus 7 is 9. And then square root of 9 is 3. 8 equals 2. No, not true. So let's try 9. 5 plus 9 plus 7. Is that equal to 9? All right, so I have 5 plus 9 plus 7 is going to be 16. Square root of 16 is 4. 5 plus 4 is 9. So yes, this one is true. So this will be my true solution. Yeah. So I'm just get through the slides and wrap this up. We got another example here. You notice we have 2 radicals here. So what I'm going to do is isolate one of them. So I'm going to take this this one here and subtract it from both sides. So now that I've done that, I got square root of x minus 3 is equal to 4 minus square root of x plus 5. Now I want to undo this root on this one here. So it means I got to raise it to the power of 2. So I got to do the same thing over here. All right, so when we do this, now I got x minus 3 equals, and now I got 4 minus this. So we got some work to do, right? So you can distribute. So now I got what? 4 times 4. I'm going to say plus, but I have positive 4 times that negative root, so I'm going to say negative. So 4 square root of x plus 5. And then I have this negative times this positive. So it's going to be negative, and it's going to be 4 plus 5. Okay. And then I'm going to take these two last ones. Negative times negative is positive. So I got the square root of x plus 5. Since they're being multiplied, I'm going to do an extra step. So I'm going to rewrite this. 4 times 4 is 16. And then I got negative 4. If you'll look, the root, in order to add or subtract, they have to be like terms. And if you'll look behind this negative 4 on both of them, they are identical. The roots and the radicands have to be identical. And they are. So now I'm going to say negative 4 minus 4. So that gives me negative 8. Let me erase this right here. So I got negative 8 square root of x plus 5. And then this here, I'm going to do an extra step. That's the same as saying this squared. What happens to that square root squared? They undo each other. All right, we've got quite a bit of work to do. So now I'm going to go ahead and put together any like terms that I could possibly put together. And I want to isolate everything over here. So let's do it. Let's subtract this x and add this 3 because I want it to go 0 over here. So we're going to line it up right here. And also don't forget we have this 5 that can go over here. So let's line it up right here. Okay, let's move it over there. Let's take this negative x and line it up here. So now I got 0 is equal to, so I got 16 plus 3 is 19 plus 5. It's going to be 24. Minus the 8 square root of x plus 5. And x minus x, that goes away, right? So let me get me some more space. And, oh, we'll just have to go through this right quick. Okay, it's not going to give me no more space. Sorry, guys. Okay, so what I want to do is isolate the root again. I'm going to have to, I guess, come up here to the top. So what I'm going to do is isolate it. So let's get this 24 to the other side. It's positive, so let's subtract it. So I got negative 24 is equal to negative 8 square root of x plus 5. I need a positive 1 coefficient on that square root, and it's a negative 8, so let's divide by the negative 8. Negative divides negative is positive. 8 goes in 24 3 times, leaves me square root of x plus 5. Now let's undo this root. In order to undo the root, let's raise it to the square. Do both sides. 3 squared is 9 is equal to x plus 5. Let's subtract the 5 from both sides. And now I got 9 minus 5 is 4 equals x. Now to check if it's a true solution, we can plug it back in, right? So that means I got 4 plus minus 3 plus 4 plus 9 or 5. Is that equal to 4? Well, 4 minus 3 is 1. Square root of 1 is 1. 4 plus 5 is 9. I'll come over here. So square root of 1 is 1. Square root of 9 is 3. And yes, 1 plus 3 is 4. 4 does equal 4. So my true solution is x equals 4. And you can plot it in your graph and check it.